Welcome. Today we are going to spend some time exploring how IBM's Sterling Transformation Extender is used to help with data translation for prior authorizations listed in CMS 0057F. If you spend any time in healthcare integration, you know we swim in an alphabet soup of acronyms. Before we dive into the technical demonstration of our mapping solution, I want to take a moment to define the key terms we will encounter. Understanding not just what these acronyms stand for, but how they interact in the real world, is crucial to understanding the interoperability challenge we are solving today. Let's start with the players in our workflow provider. This is the doctor, hospital, or medical professional providing the care or medication. In our workflow, they are the ones helping the patient and initiating the prior authorization request so that the care is paid for, and generating the clinical data to show that the care is needed. Payer. This is the health insurer or organization paying for all or part of that care. They hold the purse strings and enforce the business rules for coverage or what will be paid. CMS, or Centers for Medicare and Medicaid Services. This is the federal heavyweight. Because they administer Medicare and Medicaid, they effectively set the market standards. When CMS issues a mandate, like the new interoperability rules, the entire industry has to adapt. Next, we have the Rules of Engagement, HIPAA, or Health Insurance Portability and Accountability Act. We all know HIPAA protects patient privacy, but it is also a federal mandate that dictates exactly which electronic formats must be used for certain transactions. This strictness has really helped the healthcare industry standardize on a concrete set of data transaction formats for payers. It is also a major driver for need for the new interoperability initiatives, as payers and providers speak different languages. Payers speak X12, and providers tend to speak HL7. Da Vinci. This is a private sector initiative led by HL7 to figure out how to modernize and merge these workflows. If CMS provides the what, the Da Vinci project provides the blueprints for the how, specifically for prior authorization interoperability. Finally, we have the languages our systems speak. This is where the translation friction happens. HL7, or Health Level 7. This is the standards body typically focused on clinical data. It is the language of the provider and the electronic health record, or EHR. X12. This is the standards body focused on administrative and financial data. It is the powerhouse language of the payer. FHIR, or Fast Healthcare Interoperability Resources, a family of standards under HL7. It is designed specifically for the web, making it easier for disparate systems to communicate in real time. JSON, or JavaScript Object Notation. This is a lightweight, tagged EDI data syntax that FHIR uses. It is what modern developers and APIs want to consume. PASS, or Prior Authorization Support. This is a specific bundle of FHIR resources designed to support the prior authorization workflow from the clinical side. And lastly, the X12 278. This is the HIPAA-mandated Healthcare Services Request for Review and Response transaction. The core business challenge we are solving today is to speed up the process of prior authorization. The key technology challenge is that clinical systems want to speak FHIR and JSON, but payers tend to prefer X12, and HIPAA requires the final administrative payload sent to the payer to be an X12 278. Our mapping solution acts as the intelligent translator between these two worlds. Let's step away from the acronyms for a minute and look at the real-world impact of the current prior authorization process. Imagine a patient, Jackie. She suffers from severe, debilitating migraines and goes to see her specialist, Dr. Ross. Together, they decide the best path forward is a new, highly effective, but expensive treatment. Because of the cost, they know they need prior approval for Jackie's health plan, Unified Insurance, to cover it. What happens next is an outdated, intensely manual journey. Dr. Ross's staff initiates the request, but Unified Insurance needs more clinical proof of medical necessity. So Dr. Ross's staff prints out Jackie's medical charts, sends them via fax, and leaves voicemails for the payer's clinical review team. On the other side, Unified Insurance's staff has to manually read those faxes, key the data into their system, and route it for a medical director to review. This back-and-forth volley of faxes, portal messages, and phone calls drags on. 2 full weeks later, Jackie finally receives a letter in the mail saying her treatment was approved. For 2 weeks, she waited in pain. For 2 weeks, Dr. Ross's staff burned valuable administrative time chasing paperwork, and Unified Insurance spent unnecessary operational dollars manually processing data that already existed in an electronic health record. It was a massive headache, like a migraine, for absolutely everyone involved. And unfortunately, Jackie's story is more the rule than the exception. According to recent data from the American Medical Association, physicians and their staff spend an average of 13 hours every single week just dealing with prior authorizations. But here is the truly mind-boggling statistic. Nearly 95% of physicians report that this process actively delays access to necessary patient care, and over 80% say the delays are so bad that patients sometimes just abandon their recommended treatment altogether. We are spending billions of dollars on administrative friction that harms patient outcomes. That is the exact problem the CMS mandate and the technical mapping solution I am about to show you is designed to solve. So, how do we fix this? How do we get Jackie her medication in hours instead of weeks without forcing Unified Insurance to overhaul their entire legacy compliance system? Take a look at this flow diagram. This represents our future state architecture, and it's where our mapping solution essentially acts as a universal translator. Let's run Jackie's scenario through this modernized workflow. Just like before, Dr. Ross and Jackie sit in the office and decide on a treatment. But this time, when Dr. Ross clicks order in her electronic health record, no one prints a fax. Instead, the EHR automatically compiles the clinical data and fires off a modern FHIR pass request in web-friendly JSON syntax that clinical systems understand. But Unified Insurance can't legally or technically ingest that FHIR bundle directly. Here is where the magic happens. ITX gets that FHIR pass request in real time and translates it into a HIPAA-compliant X12 278 request. Unified Insurance's system receives the standard 278 transaction it expects. Because the data is structured and complete, it bypasses manual data entry and goes straight into their automated rules engine for review. The system approves the medical necessity and immediately kicks back an X12 278 response. ITX takes that 278 response, translates it into a FHIR pass response, which is sent into Dr. Ross's clinical system. Dr. Ross gets an alert on her screen that the treatment is approved perhaps even before Jackie leaves the exam room. The provider stays in their clinical workflow, the payer stays compliant with their administrative standards, and the patient gets quicker access to care. Let's zoom in and focus on the data flow. This diagram lays out our two distinct data standards, HL7 FHIR on the left and X12 on the right. Now I'll take you into the software to demonstrate how we use ITX and the Pack for Healthcare to automatically power this translation. To get started, the good news is that we do not have to build these translations from scratch. Within the Pack for Healthcare, we provide a pre-built asset called the HL7 Example FHIR Pass JSON. I am going to import this zip file directly into our designer user interface. I'll name this specific project Pass so we have a clean, dedicated workspace for our prior authorization flows. Now, while this gives us the core translation logic out of the box, it is intentionally packaged as a customizable template. Every healthcare organization has unique routing rules or specific payer identifiers, and we will look at how easily you can tailor those values in just a moment. But right away, you can see our workspace is successfully populated. We have our schemas to define the data structures and our maps ready to do the heavy lifting of translating FHIR to X12. You can open your maps either from the quick links or from the menu bar. We're going to look specifically at the pass request maps. Here we see the browser-based map designer. Our input data is a JSON-formatted FHIR request bundle. As we expand this structure, we can see the various layers of the JSON message all the way down to all of the possible resources. We are mapping this structure directly to X12. For this demonstration, we are going to create a single interchange with a single functional group, which is our 278 transaction. As we navigate into the interior details of this transaction, we can visualize how easily you can drag and drop components from our input into our output. As I mentioned earlier, these mappings are labeled as an example because there are specific elements your organization will want to change, such as syntax items and the party identifiers we see here. Let's take a look inside the actual transaction set mapping for this request. Notice that we use functional maps to help us divide the mapping work into manageable, modular sections. Here are the details of each transaction set within this map. One of the interesting things about this map, which those of you familiar with mapping into EDI will really appreciate, is that we can easily use data we have already calculated in an output and map it back onto that same output. We can see this happening directly in the diagram. We have one input file and one output file, but we can see output 1 mapping to itself. In X12, for example, we must ensure that the control number in the ST header matches the control number in the SE trailer, and that the total count of segments in the transaction is calculated and placed in the SE trailer. This is easily accomplished right here using the map designer. Now that we understand what our map is doing, let's build and run it so we can look at some test data. We'll examine both the before state with the data in FHIR form and the after state once it has been converted into a HIPAA-compliant X12 278 transaction. Here we are building our map. And now we will execute the mapping logic. From the structure diagram on the right, we can easily access the map logs, audit trails, and traces, as well as the input and output data results. To see exactly what our map accomplished, let's look at the input data and scroll through the example file we started with. We can see that this is a FHIR claim resource. This should look familiar, as it is structured just like the map input card we reviewed earlier. One of the key data points here is the Utilization Management Organization, or UMO, identifier, which is 123450000. We also see the provider name is Doctor Group, and the patient name is Joe Smith. Next, let's look at the output data that was generated. Once again, this structure should look familiar because it mirrors the output card of our map. If we examine the translated X12 data, we can verify our key fields came across perfectly. The UMO number is 123450000. The provider name is mapped as Dr. Group, and the patient name is Joe Smith. As you can see, from this single FHIR bundle example, we successfully generated a fully compliant, structured X12 278 request.